The input-output discrete and analog modules that we talked before, it's used to interface between the ordinary devices like switch, sensors, actuators, and the microcontroller or the CPU unit. However, there are some special modules which need to be used with some specific devices as interface also between that device and the CPU unit. One of these modules is the high-speed counter modules, which are used to count the pulses from the sensors, encoders, and switches that operate at very high speed. So the normal or the ordinary interface, either input or output in the interface, cannot receive the data from such high-speed counter modules. So we need to use some specific modules to interface between the high-speed devices or high-speed counters and the PLC system. Such modules can count up to 100,000 pulses per second. So it has a frequency of count rate at up to 100 kilohertz. So it can count the pulses here, train and pulse, as you can see here, that's generated by encoder or some type of stepper motors and so on. These high-speed pulses can be counted by the PLC by using such specific modules for interfacing between the input counter and the PLC system. Second type of the special modules here is the thumb wheel module, which allows the use of thumb wheel switch for feeding information. So we have here some like a counter here. In order to get these readings here into the PLC system or to the programmable logic control system, to perform some operation control, we need to use such modules in order to interface between the counter or the thumb wheel module here and I mean the counters and the PLC system. So the data can be fed from these modules to the CPU unit. Another module here also we call it the TTL module, which is used for receive the signal from transistor logic. This type of module here, for transistor logic, it generates some pulses or some voltage at a specific level for electronic circuits. In order to receive such signals by our PLC, we need to use specific module. We call it TTL module. Another module we call it encoder counter module here. This is the encoder counter module. Also, it's used also to interface between the encoder and the PLC to receive the data from that encoder and forward to PLC for use for any uh, further processing by the CPU unit in real time. Actually, all these modules are special or are used for specific input or output devices. It cannot be used for other devices. Only each module is used for its specific device. Another module here or another special module is the BASCII or ASCII module here, which run to use for the, as we mentioned, you see before here, for scanner or decoder. For reader here, in order to use for the barcode readers, we use special module here, which can read the or we can update the data from the barcode here into the PLC system. So can the model here, it will be interface between the barcode reader unit and the PLC system. So the data that will be collected from this reader unit will be forward to the programmable logic controller unit or CPU. Also here we have the stepper motor module, which used with the stepper motor. We studied in chapter 1 about the two type of the actuators, which is stepper motor and servo motor. And here for the stepper motor, we have to use this specific module to connect the stepper motor to the CPU unit. So this module will be interface between the stepper motor and it will send the data from the stepper motor, either about the data of the for the speed of the stepper motor, by providing a train of pulses and update to the PLC system. So this data later on will be used to monitor such stepper motor or to take any uh, control action in the process under control. Also, we have the BCD output modules here, and this BCD output module is used to display some digit. Actually, this represent actually the either the BCD or the previous one, which is the stepper motor. Both are actuators, and they represent like special modules for the output here, while some of the previous modules are for the input. So it depends if it will be connected to the actuator. So we call it output module interface. If it will be connected to the input devices, it will be input module interface. So here the BCD output module enable the PLC to operate devices that require BCD code signal, such as 7-segment display. So we have here the 7-segment display. We want to use it with the PLC. In order to connect this to PLC, we need to use the BCD output module. The operational integral derivative, which is the PID module here, we already mentioned for it in chapter 1. And when we talk about the type of the controller, we mentioned for the proportional integral derivative controller, which is represent algorithm for performing integral or derivative in addition to the proportional action for the control signal. So in order to connect this or to use such BID controller with the PLC system, we need to use this specific module here to interface between the PID algorithm and the PLC units. So for that, this PID equation here will be used to adjust, for example, the output of the controller to control the actuator or the valve here. So it will take the signal from the controller, go through this operational algorithm, I mean either the proportional or integral or derivative, to perform the control. We mentioned before we for BID here we use it with the PLC in order to prevent the CPU or to decrease the load on the CPU. I mean, instead of leave the CPU to perform some complicated calculations, it's better to use PID module here with the CPU. So the PID will be responsible to perform such complex calculation, either integration or derivative and so on, and not burden the CPU. So the CPU can perform other operations. It's like sharing the load with the CPU unit. Also, we have one another module, which is motion and position and control modules, which are used to in application involving for accurate high-speed machining or packaging operations. So in the industry, when we use to either in the packaging or the machining operations, we need to use high speed machines and so on, and we want to put such operation under control of the PLC system. We have to use such motion and position and control modules to interface this either the servo motor or stepper motor with our PLC system. So this model here will be used like interface between the servo motor or which need require some high speeds and the PLC input or PLC output units. So it can be used with both either stepper or servo motors. Serial communication modules here, and the serial communication module actually is used to establish a point-to-point communication between the CPU unit and I mean between the PLC unit and for example server or some intelligent or smart devices. So if you want to connect your PLC to an external device, which is a smart device, which can communicate with PLC or support the communication with PLC, we need to use some special serial communication modules to connect this device with our PLC or with the device with the server or with the computer. So usually this use or the communication modules have provide for connection to the PLC network. I mean, if we have multiple PLC system also like we want to control multiple process, each process it has its own local PLC system. So we want to control to connect the different PLC network here. We can use such serial communication modules. That's all about this part. We will move to the next video.